What we're going to take a look at here is graphing quadratics that are in intercept form. And the quadratic that we'll work with is y equals x plus 4 times x minus 2. So intercept form is written as two binomials. A binomial is just having two terms, x plus something or x minus something, and then another binomial, x minus something or x plus something on the other side. The reason why it's called intercept form is because we can identify our x-intercepts right from here. We know that our x-intercepts are when y equals 0 along this line. So what we ended up doing is, if we were to set this equal to 0, alright, we would go through and say, alright, what's going to end up making this true? And due to the zero product property, we say we could set x plus 4 equal to 0 and also set x minus 2 equal to 0. And we go through and we solve these. We get x equals negative 4, and we get that x equals 2. So what that's telling me is when I plug in negative 4, I should get a y value of 0. And when I plug in x equals 2, I should also get a y value of 0. So those are my first 2 points, and I can look at that just structurally from here. I see x plus 4, what's going to end up making that 0? X equals negative 4. X minus 2, what's going to end up making that equal to 0? X equals 2. So I go through and I plot these 2 points down. 1, 2, 3, 4. There's my negative 4, 0. And I would also plot 2, 0. Now, from here, just like before, we have 2 points, but we have to still identify where the vertex is going to be, and that's always the key point here. And just like we had seen in standard form, when we have 2 points that have the same y value, the vertex should be directly in the middle of those 2 points. So if my vertex, if I have between these 2 points, there are 6 x values, 1, 2, 3, 4, 5, 6, my vertex should be located directly in the middle, which would be 3 away. So my vertex should have an x value of negative 1. Whether it ends up being up here or down here, that doesn't matter, but it should be directly in the middle of these 2 points. They should be the same distance apart from the vertex because they have the same y value, which is something we had seen in class and in looking at things in standard form. So I identify my vertex is going to have an x value of negative 1 because that's the x value that's directly between negative 4 and 2 for this. So what you could do, if you're not seeing that, you could add 2 and negative 4 together and divide it by 2. What you would get is negative 2 over 2, which gives us an x value of negative 1. That's another way that we can look at it, but again, it's just looking and finding out what's directly in the middle of these 2 x values. So we get our x coordinate is negative 1. Now, just like what we had done in standard form, we need to plug that negative 1 into the function to find out what our y value is going to be. So I'm going to plug in f of negative 1 into my original function. So negative 1 plus 4, and then negative 1 minus 2. So I go through, negative 1 plus 4 is 3, negative 1 minus 2 is negative 3. What that ends up giving me is negative 9. So I would have a vertex of negative 1, negative 9, which I could say here's negative 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my vertex of 1, negative 9. And now, from here, this is all I need to draw this. Alright, I have my 2 intercepts, and then I have my vertex. I'm going to go through and sketch my parabola, looking like something like this. Okay. Alright, it's not going to, doesn't have to be pretty. Mine is not at all. But it should be relatively a U shape. Okay, that's not good. Alright, and that's really what I have to do from there. But it's important, especially when your graph doesn't look so good like mine, that we label the points that we ended up going through and finding. And again, with all these quadratics, we're going to be asked what's the minimum or the maximum value. We can identify the minimum value here by the vertex, which is 1, negative 9, and we can say it's a minimum. Our maximum is going to end up being infinity. These lines are going to continue to go forever and ever because of the arrow, so there's no way that I can identify what the maximum is actually going to be.